Hello, everyone, and a very warm welcome. I'm absolutely thrilled to have you here for today's explainer on arithmetic progressions. Today, we are focusing on a truly powerful, beautiful mathematical concept, finding the sum of the first n terms. So settle in, get comfortable, and let's dive right into the magic of numbers together. Created by Mindsticks Foundation Trust. All right, here's our game plan for today. We'll start by deriving the sum formula, then look at a handy first and last shortcut, explore some special number sequences, tackle a few practice problems, and finally apply all of this to real-world scenarios. Let's get started. Section 1, deriving the sum formula. You see, in math, we never just memorize formulas blindly. We really want to understand exactly where they come from. Before we jump into the derivation, let's quickly get our basics straight. We use Sn to represent the sum of the first n terms of our arithmetic progression. Now, A is our very first term, and D is the common difference. That's the constant jump from one term to the next. Simple enough, right? Keep these carefully in your mind. Now watch this beautifully clever trick. To find the sum, we write out the entire S sub n sequence forwards, and then right below it, we write the exact same sequence totally in reverse. When you add them vertically, pair by pair, something absolutely magical happens. Every single pair adds up to the exact same value. That gives us 2 times S sub n. Divide that by 2, and boom, we have our master formula. S sub n equals n by 2, multiplied by 2a plus n minus 1 times d. Amazing, isn't it? Let's actually see this formula in action. Take a look at this example. We need to find the sum of the first 100 terms of the AP, 14, 16, 18, and so on. So what do we have? Our first term, a, is 14. Our common difference, d, is clearly 2. And n is 100. We just plug these values directly into the formula we just built. And we get 11,300. Think about how incredibly powerful that is. Instead of sitting there manually adding 100 numbers, which, let's be honest, would take ages and you'd probably make a mistake, our formula handles this massive addition problem effortlessly in just a couple of lines. Moving right along to section 2, the first and last shortcut. Because sometimes we want an even quicker way. Here's the deal. If you already know your very first term, which we call T1 or A, and you also know the very last term of your sequence, Tn, you can use this super elegant shortcut. Sn equals n by 2 multiplied by just the first term plus the last term. It's quick, it's clean, and it's highly effective. Let's apply it right here. Look at example 1, finding the sum of the first n natural numbers. The first term is 1, and the last term is simply n. Plug those into our shortcut, and you instantly get n times n plus 1, all divided by 2. No heavy calculations, just pure logical substitution. All right, section 3, special number sequences. Math is all about patterns, and arithmetic progressions help us unlock some really beautiful ones. Just look at these beautifully simple rules that pop out. For the first n natural numbers, the sum is n times n plus 1 over 2. For even numbers, it simplifies straight down to n times 1 plus n. And my absolute favorite, the sum of the first n odd numbers is just n squared. Honestly, isn't that a wonderful pattern? Let's put that to the test with example 4. We want the sum of all odd numbers from 1 to 150. Now, pay close attention here, please. You absolutely cannot just use 150 as your n. First, you have to figure out exactly how many odd numbers are actually in that range. Using our nth term formula, we find that 149 is the 75th odd number, so n equals 75. Always find your n first before substituting to find your final sum. Don't fall into that trap. Okay, section 4, solving practice problems. Theory is great, but getting your hands dirty with actual problems is where the real learning happens. Check out this activity from practice set 3.3. We're given the first term a as 6 and the common difference d as 3. We need s27. By literally filling in these boxes step by step, you're training your brain on the logical flow. See how it guides you? Insert the formula, plug in n, a, and d, and then just do the basic arithmetic. And now we're at section 5, real-world AP applications. This is where we take all this abstract math and bring it straight into the real world. Imagine you're managing a factory. Here's your problem. The factory makes 600 mixers in its 3rd year, and by its 7th year, it's making 700 mixers. Assuming a steady, constant growth every year, how many mixers did this factory produce on day 1 in its very first year? Let's figure this out together. Since we're assuming a constant increase in production each year, we know for a fact that these numbers form a perfect arithmetic progression. That steady growth we talked about, that is quite literally our common difference in real life.
So let's walk through the math. Step 1, the third term, t3, is 600, and the seventh term, t7, is 700. Step 2, we form our equations. A plus 2d equals 600, and a plus 6d equals 700. Step 3, simply subtract the smaller equation from the larger one. The a cancels out perfectly, leaving 4d equals 100, which means our common difference d is 25. Step 4, substitute that 25 back into the first equation, and we isolate a.
And there we have it, 550. That's our aha moment, right? Using nothing but AP rules, we essentially time traveled to find out the factory made exactly 550 mixers in year 1. But wait, there's more. We can take those exact same values, A is 550, D is 25, and project straight into the future. Plug them into the 10th term formula, and we predict exactly 775 mixers in year 10. Math literally lets us see the past and predict the future of this business. So I'll leave you with this final thought. How can you apply arithmetic progressions to predict patterns in your own life or career? Maybe it's tracking your savings, mapping out a new skill, or projecting business growth. The magic of math is truly everywhere around us. Thank you so much for joining me in this explainer today. Keep practicing, keep questioning, and keep learning.